Okay, I think we're almost good to go. Let's see, confirm live viewing. I think we're good to go, 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 good to go. We are good to go, good to go, good to go, good to go. Right, I think we're good to go. Yes, I think we have confirmation that everything is going on fine, so we can start our class. Good evening. Once again, you're on to the Midnight Sun project. It is Mamu Jarvis. And I want to trust you have been following us on YouTube and you've enjoyed our classes. We've had like about 1 week officially now on this project. And we want to keep it up on that. A quick reminder here that the project essentially focused on, or is going to be focusing on our grade 12 WAEC NECO exams, but this class can be can suit the audience of those in grade 9, 10, 11, and 12. Depends on your knowledge level. We've also tried to scale the learning approach down so that students in these classes can effectively learn what we're doing. So we're going to start, as is our practice, to go through past question papers, and I have a handful of them here. We're going to see how much time allows us to go through this work. So we'll start today by looking at a branch of arithmetic. If you've seen my post already, we're going to continue from numerical processes. Numerical processes, part 2. And then our numerical processes will focus on our non-use of what, or our non-attendance to word problem. We'll not be looking at word problem. We're looking at questions straight away from WAEC that are arithmetic in nature, but not word problem. So this class can actually be attended by those in grade 7. Some of the questions are grade 7 questions. Some of them are grade 8. Some of them are grade 9, 10, 11, 12. So let's hit the road. We kickstart our work today by looking at WAEC 2000, which one is that? 2004. And it's a November exam and it's OBJ. So if you have that question paper, we're looking at question number 1. It says express 0.015849 and correct that to 3 significant figures. Express 0.015849 expressed to what? 3 significant figures. Now, 3 significant figures will, for a pure decimal number, will start from where you're seeing a whole number. If you look at this problem carefully, you discover that the whole number, the first whole number you're going to see, or the first digit, non-zero digit, that should be the right word to say. The first non-zero digit is 1. So because they said 3 significant figures, we're going to be looking at 1, 2, 3. So this becomes the digit of interest, and this becomes the digit causing the approximation. Now, what will cause the approximation is not up to 5, so we would say that the answer will simply be what? 0.0158, and that clears that question. We go to question number 2 on that same year, and this time around is testing your knowledge of fractions. Testing your knowledge of what? fractions. All right, so we have a problem 1, 3 over 5 plus 1 whole number 1 over 8. I'm having a feeling that I've solved this before, but solving again, that will not be a problem. Times 65, 16 over 45. Now, board mass will apply here. So to this part, I'm going to change to improper fraction by way of board mass or big maths. It will mean that we take care of this part first. And that will be 1, 3 over 5 plus, I will change the improper fraction 9 over 8 times what? 16 over what? 45. So if I cancel this, now you can divide both. I'm going to have 5, I'm going to have 1. I'm going to have here 1, I'm going to have here 2. So I'm going to have 2 over 5, which is what? I said I've solved this question before. 3 over 5 plus 2 over 5. Now 3 over 5 plus 2 over 5 will give us 1. 1 plus 1 will give me what? 2. We call this like fractions. When fractions are said to be alike if their denominators are the same. When fractions denominators are the same, we say that those fractions are what? Alike. So we say hence we're not treating word problem. Let me see the other questions that will relate to this, and if they are none, we can call it quits with this question here. All right, I don't think there's any other one, but I think I have 2 question papers of this year. I think that's why this problem is occurring. I have 2 question papers of this year, and I'm sure I'm solving the same year again. All right, so we come to 2015 WAEC, 2015 OBJ, and it's a June exam. And it's not OBJ, sorry about that, that's theory, sorry about that. It's a theory exam. All right, now it's question 1A. That theory question is 1A. And we are told to solve without using mathematical tables or calculator. Whenever they tell you to solve without using mathematical tables or calculator, it means process is very important. All right, so let's look at the question. The question says 3 whole number 4 over 9 divided by bracket open 5 whole number 1 over 3 minus 2 whole number 3 over 4 plus 5 whole number 9 over 10. Is that okay? All right, so this is a question we're told to solve. Now, how do we solve this? I'll just write my board maths or big maths on the board, just to give us direction to where we are going to. Okay, so with that said, this will now give us, we'll take care of this one first. We'll take care of this first. So I could just put an asterisk and I'll take care of this. So 5 minus 2 will give me what? 3. 5 minus 2 will give me 3. Some students will convert to improper fraction and solve. Well, it's not much of an issue. You can do that, but I always tend to avoid that approach because sometimes when you use certain approach or approaches, you lose the essence of some key knowledge you need to gather. All right, so the LCM of 3 and 4 will be 12. LCM of 3 and 4 will be 12. And with that, 12 divided 3 will give me 4. 4 times 1, 4 minus 12 divide 4. All right, 12 divided by 4 will give me 3. 3 times 3 will give me 9. So with what I have now, I will reduce this to what? 2 and add, for every one whole number here, I need to divide it to what? 12 parts. So this will be 2 whole number. 12 plus 4 minus 9 over 12. And if I do my maths well, this will be what? 2 whole number 16 minus 9 divided by 12. And that will be 2 whole number 7 over 12. So that will be 2 whole number 7 over 12. So with that, I can now rewrite this. This will now be 3 whole number 4 over 9 divided by 2 whole number 7 over 12 plus 5, 9 over 10. So with that done, I need to take care of this. So to take care of this now, I'm going to do division next. And that means this 2. I'll change the improper fraction. If I do that, this becomes 31 over 9. Hope I got that right. 3 times 9 will give me what? 3 times 9 will give me 27. 27 plus 4 will give me 31. Divided by what? 2 times 12 will give me 24. 24 plus 7. 24 plus 7 will give me 31. Plus what? 5 whole number 9 over 10. And this is where I have to be very careful because in one of my videos, I discovered an error I made and I had to do a 1 minute makeup video to correct that error. So let's look at this. This will be 31 over 9 times 9 over 31 plus 5 whole number 9 over 10. And when we cancel this, we're going to have 1. That's 1 plus 5 whole number 9 over 10. And 1 plus 5, 1 will be added to the whole number part. And that becomes 6 whole number 9 over 10. Like I've always said, I'm really not so bothered if at the end of the day I solve and I don't get the answer. Because that's not my objective. My objective is to ensure that you see the process we need to apply. And if for any reason you're able to spot an error I have made, for me, that means learning has taken place. All right, so let's go. I think we're done with that question. And as a matter of practice, like I've always said in my videos, I try as much as possible not to solve questions before I come. And I do that deliberately so that I can put myself in the examination setup and see if this were to be an exam for me, how would I have what? Fared, right? So just to check. So I'm not bothered if I have to embarrass myself online just to ensure that I'm teaching you what you ought to know correctly. Right, if that is done, we will try to look at another question paper and see if, all right, so we look at another question paper, and this one is November, WAEC, November 1998. Incidentally, this was the exam year I wrote some years back then. And I remember I was taking a student on this and I showed her the question paper. She was like, wow. And what was so interesting was that back then I was even getting the questions. I was getting the questions. She was like, oh, you're getting the answers. So it's such an interesting thing to do and to see that we can actually make progress in our work. So this is OBJ, and we will be considering question 34. November 1998, question number 34. And the question says 1 over 5 times bracket over 1 over 2 minus 1 over 3. And this is a question we are told to solve. That's the question we're told to solve. Notice that there are questions revolving around fractions, and we expect 1 mark is important in an exam. 1 mark will be the key decider whether you're going to get a C6 or a P7. So we don't leave any stone unturned. Okay, if that is done, the bracket suggests that I need to take care of this first. So I just put an asterisk here and I take care of this. The LCM of 2 and 3 will be 6. I want to trust you can find LCM. And with that said, 6 divided by 2 will give me 3. 3 times 1, that is 3, minus 6 divided by 3, that will give me 2. 2 times 1, that is 2. That will be 1 over 5. So where I have this, I'm going to replace it with this. So I'm going to have 1 whole number 1 over 5 times 1 over 5. So hope I got that right. Hope I'm spot on there. Right, I think I am. So this will give me what? 6 over 5 times 1 over 5. 1/6. Sorry about that. Thanks for that. You know, sometimes when you're solving problems and you just discover something funny, I know that there was something odd, but I couldn't place what it was, so I can cancel out. And my final answer becomes 1/5. All right, so that's solved for that. Let's see if we have other questions like that. The other questions we have here are essentially word problem, but the purpose of this class is not to attend to word problem, but to deal with problems not involving word problems. So maybe perhaps other classes, I'll take care of that. Okay, let's take a little. I just realized that I've just been solving. So let's take a minute or two break to cool ourselves down, and then we'll continue. Okay, I guess you've rested enough, so I can continue with my work. All right. Okay, so we go to the next question, and that will be taken from June WAEC, June 2003, and it's an OBJ setup. So we look at question number 1. Question number 1 says, bracket open 3/4 minus 1/3, if I got that right, times 4 1/3 divided by real number 1/4. Now, I'm going to give you something that will really shock you here. Now, you can actually be treating these brackets and be treating this one simultaneously, and no harm will be done in solving. Now, let's treat this first, just for the purpose of helping us to understand what we ought to do. This will be 3/4 minus 1/3. LCM of 4 and 3 will be 12. 12 divided by 4 will give me 3, and 3 multiplied in numerator will give me 9, minus 12 divided by 3 will give me 4. 4 times 4 will give me 4. So that will give me what? 9 minus 4 will give me 5/12. So if that is understood, where I have this now, I'm going to replace it with this. And that will mean that I'm going to have, sometimes you can just rule off to tell the examiner that I'm through with this idea. Now I'm coming back to the problem. So this will now give me 5/12 times, I'll change this to a proper fraction, 13/3. Somebody in data, we got that. 3 times 4 will give me 12, plus 1 will give me 13, and divided by what? 3 times 4 will give me 12, plus 1 will give me what? 13/4. So this will now be 5/12 times 13/3. And the division sign here will suggest that it will cause a toggling effect here, and this will be times 4/13. So what's going to happen? This will conveniently cancel this. This will go here 1. This will go here 3. So my final answer will now be 5/9. Where's the 9 coming from? 3 times 3. And that will be 5/9. That solves that question. So let's see the other questions like that in the question paper. Let's see the other questions like that in the question paper. Okay, there's one like that. Some scholars may argue that we should have taken that to algebra, but I think we can actually solve it as arithmetic. So, because it has in it the concept of fraction. So let's look at it. This is one of those questions I call hybrid. They're hybrid questions. All squared minus 2/3 all squared. So before I start solving it, I will convert this to a proper fraction just to bring perspective to the question. I'll convert it to what? Improper fraction, just to bring what? Perspective to the question. Now, this will be equal to 5/3. How did I get that? 3 times 1 will give me 3 plus 2, that's 5, all squared, minus what? 2/3 all squared. Now, how do we simplify this out? Look at this. This is squared, separated by what? Subtraction. Squared, separated by what? Subtraction. So it will mean difference of two squares. And there's a formula for that. If I have a squared minus b squared, the interpretation will be what? A plus b into a minus b. So if this knowledge is clear to us and we want to be very thorough with what we've done, this will simply be what? I add this. Anytime you see this, it means add this and then multiply by the subtraction. So 5/3 plus 2/3 into 5/3 minus 2/3. Sorry about that. These are what we call like fractions, so we can add them. So we close our eyes to the denominator and add the numerator. So 5 plus 2 give me what? 7/3. Now, look at this. These are like fractions too. So I'll close my eyes to the denominator and I'll subtract the numerator. 5 minus 2 give me 3. And this will reduce to 1. So it's like saying 7/3 times 1. And then that final answer becomes 7/3. Now, in your question paper, do you have 7/3? Of course not. So you'll be required to convert this to what? To what? Mixed number. So this will be what? 2 whole number 1/3. Did I get that? How many 3's can I get from 7? 2. What is left? 1 divided by what? 3. So that will be 2 whole number 1/3. And that settles that question. I want to trust that that one is taken care of. Let's see the other questions in this year that require attention in that manner. And if there's none like that, we can say safely that we should go to. Okay, there's one here again, question 31. Did I state that question number? I said that this is question 11. And then we can quickly try to look at question 31. Question number 31. After that, we'll take another short break and then we'll cool our brains and we're back. We'll go back. Now, question 31. In question number 31, it says, given that x is approximately 0.0102 towards 3SF. Which of the following cannot be the value of x? So I'm going to write the options down. Now, which of these or this cannot be the correct? Which of these cannot be the correct, or which one cannot be the correct answer? So let's start with this one. This is 3 significant figures. As long as this digit is significant, anything following that becomes what? Significant also. So it's 1, 2, 3. Digit of interest, digit causing the approximation. This is 5 and above, so it can toggle. This is 5 and above, you can toggle this. This one is already 2, this is 1, it can't toggle, so it means this is correct. So this will be the right answer because this is digit of interest. The digit causing the approximation is not up to 5. And because that digit is not to 5, it will not cause any addition to this. So this becomes the correct answer. That one cannot be that one will not be an answer that will give you 3 significant figures, right? So we're done with that. And we'll take a little 1 minute or 2 minutes break to cool our brains, and we're back. We're going to come back. Okay, so I guess we're done with that. You'll notice that the questions are quite simple. So they're not questions that will take so much of your time in the exam. And usually, we don't expect to spend more than a minute or two in questions like this. And for exams where you have to use calculator, you discover that some of these things I'm doing may not be, process I'm going through may not be necessary. I solve with a mindset that you are answering theory questions. You get that? So you pardon me if I go in this route. I'm solving with a mindset that you're solving a theory question. But usually in an exam setup, if it's OBJ, you would be required to use a calculator. Nobody will investigate. All they want to see is the correct answer. So some of these questions, you can actually use your calculator to solve them. Right? So let's look at another year. This is WAEC 2016, WAEC 2016. And the question is OBJ, and it's question number 1. Question number 1A, and it says, without using mathematical tables, so without using mathematical tables or calculator. Without using mathematical tables or calculators, evaluate what? 0.09 times 1.21 divided by 3.3 times 0.00025. And you are told to leave your answer in standard form. Another word for standard form is scientific notation. Let's write that. Leave your answer in standard form. And that is what is called scientific notation. So please take note of this. I took out time to write the question because I wanted to pass a very important idea across to us. When solving problems, you must read your questions very well. Don't assume you know it. That's the fastest way to fill a question. Look at the question given to you, pass it's given to you, and then you attend to it. So you're told to use what? To leave your answer in scientific notation. Now, this is a question we are giving. So how do you solve this? Anytime you are giving a question like this, please, and you're asked not to use a calculator, the first thing you must do is to make the decimals whole numbers. Make the decimals what? Whole numbers. How do you do that? You count the number of decimal places. 1, 2, 3, 4. So you have 1, 2, 1, 2. 2 plus 2 is 4. You come to the denominator, 1. This one is 1, 2, 3, 4, 5. 5 plus 1 is 6. So I have 6 decimal places here. I have 4 decimal places here. Now, if I apply 6 here, I will have a 2 remaining. That remaining 2, I must account for it here. So from this point, I'm going to have what? 9 times 121. Remember, there are 6 decimal places here. Those 6 decimal places I have moved correspond to what? 10 raised to the power of what? 6. So if I move just 4 decimal places here, I will need to move 2 extra decimal places on top. Is that not? So that will be times 10 raised to the power of what? 2. Because 6 minus 2 will give me 6 minus 4, rather, will give me 2. So that's settled. I'll come to the bottom and have what? 33 times what? 25. So what do? I will need to cancel out. Now, so watch how the cancellations will take place. If I divide this by 11, I'm going to get 3 here. If I divide this by 11, I'm going to get 11 here. Because 11 squared will give me 121. I can divide this by 3, I'll get 1. Divide this by 3, I'm going to get what? 3. Get that? So with this done, I will have what? 3 times 11 times 10 raised to the power of 2 will be what? 100. Divided by what? 25. Because I've reduced this to 1. Now I can divide this by 5 first, I'll get 5. I'll divide this by 5, I'll get what? 20. Another 5, 1. Another 5, 4. So what would the answer be? 3 times 11 will give me 33. 33 times 4 will give me what? 132. Let's see that. 33 times 4. 2 will carry off 1. That's 12, carry off 1. 3 times 4 will give me 12 plus 1, 13. So that will be 132. So the answer to that question will simply be what? 132. Right? Okay, so we'll take a little breath and then we'll continue with our work. Take a little breath and then we'll continue with our work. Right. Okay, so let's see. All right, I think we should call it a day today. It's supposed to be a 1-hour class, but I'm looking at the logistics I put in place to help my work today. So I think we'll call it a day on this. Numerical processes will still continue after now. And I want you to go back and pick some of these questions, whether WIAC, whether Cambridge, and try to see if you can solve questions. In the course of this class too, I'll be picking some questions from Cambridge. I'm going to be picking some Cambridge questions. So it really doesn't matter whether it's WIAC, NECO, or Cambridge. What's most important is that the understanding is passed across to us. Mamo will return with a MIDNITE Sun project tomorrow. And although we've done only 30 minutes, like I've just apologized, I'm looking at the logistics I've put in place for my class tonight. And I don't want to leave this class having issues. So I'll leave you tonight. Enjoy your night, and don't forget to keep solving mathematics. God bless you.